In this video, we'll be finding the arc length of specific curves. This allows us to do it in such a way so that we find the exact length of a curve as opposed to the exact length of a straight line. This will do this using the concept of the distance formula. So in here, we're looking at the integral from a to b of the square root of 1 plus the derivative function squared inside that square root dx. We also have a formula in terms of y. You'll notice that these two formulas are very similar. The only difference is that the function is in terms of x and we take its derivative. Down here it's the function in terms of y and we take its derivative. Notice also the bounds will change based on it being in terms of y. So our first function we're looking at is y equals natural log of the secant of x. We're doing this in the bounds from 0 to pi over 4, so we'll be using this equation up here because it's all in terms of x. So our first step is to take the derivative. So this is f of x is equal to the natural log of secant of x. We take the derivative, f prime of x is equal to the derivative natural log of anything is 1 over that anything, times the derivative of the inside, so the derivative of secant is secant tan. But you'll notice that if this is rewritten, we have the secant of x tangent of x divided by the secant of x, and those two secants can cancel out, leaving us with just the tangent of x. At this point, we're going to go ahead and again utilize this formula, plugging tangent of x in for the derivative, squaring it, adding 1 to it, and then square rooting it. So I'm going to have the arc length is equal to the integral from 0 to pi over 4, because those were the bounds we were given, 0 to pi over 4, of the square root of 1 plus tangent squared x in regards to dx. Now to manipulate this formula and this function, we're going to have the integral from 0 to pi over 4 of the square root of, well, 1 plus tangent of x. If you recall, that's nothing more than secant squared. So this becomes secant squared x dx. And then this is going to be the integral from 0 to pi over 4 of secant of x dx. So your next step is to integrate this particular function. However, with our skills, we can't do this analytically. So you will not see one like this. However, the integral of secant of x is nothing more than the natural log of the absolute value of secant of x plus tangent of x. So in this case, we're evaluating this function going from 0 to pi over 4. In this case, when I plug in pi over 4 to this function, I'm going to have the natural log of the secant of pi over 4 plus the tangent of pi over 4. Keep in mind this is all inside that natural log function, and it's all absolute valued, minus the natural log of the absolute value of the secant of 0 plus the tangent of 0. And evaluating these functions here appropriately based on the unit circle will provide you with the value you're looking for.